Welcome, everybody. This is Don Shu for 26.1 AI Podcast, coming to you from Create 33 in Seattle. Create 33 is a founder focused co working solution associated with Madrona Ventures, one of Seattle's largest venture capital groups. Today, we have Algorithmia founder and CTO Kenny Daniel. Kenny is fresh off of a $25 million Series B raise that completed in May. Prior to founding Algorithmia with Diego Oppenheimer, Kenny built out image recognition systems for Delectable, a wine app. He attended undergrad at Carnegie Mellon with his fellow founder Diego. Currently, Kenny is on leave from a doctorate program at USC where he researched AI and mechanism design. Personally, I'm indebted to Kenny for being one of Puppy's first celebrity speakers when Algorithmia was making headlines as one of Seattle's hottest new startups.
Welcome, Kenny.
Great. Thanks to be on, Don and Brian.
Welcome, Kenny. Welcome. And I hear you and Don are in the same room together in Seattle, and I'm down in LA. Can you just give us a quick background on kind of how you got here today and what led you to be here in the seat right now?
Yeah, absolutely. So as Don mentioned, my background for a while, I was in academia studying AI and machine learning, among other things. And it was during my time there that a lot of these ideas sort of started to format in my head. Myself and my colleagues in academia, we were developing these new algorithms and these new models, on a constant basis and working really hard to, develop them, write about them, present them in conferences and get the word out. But I got increasingly frustrated by seeing all these tools and really important things being built that could be useful in the real world, but not actually getting out into the hands of people who could use it. And seeing that, there was a number of challenges that sort of led into that. But as I started talking with my co-founder, Diego, so he's the CEO, I'm the CTO of Algorithmia, he came at it from the industry point of view. So he was working here at Microsoft. That's our Seattle connection as a company. And so he saw it from the industry side of things, of the challenges of adopting AI and machine learning, even at a giant company like Microsoft that has a lot of resources. So you can only imagine how much more difficult it's going to be at a smaller company or a company that's not even necessarily a tech company, but could still really benefit from these sorts of things that are being built. So with that as sort of the initial idea that led to these discussions, we started talking about what could we do to make algorithms, data science, machine learning, and AI more accessible? What are the challenges that are being faced by both the developers of these tools and by the companies that want to use them? And that was where we started going down this road of sort of infrastructure and tools and services around AI and machine learning.
And I certainly know firsthand that it can be a challenge to deploy machine learning models in production. And it sounds like you have experienced this as well. Can you speak a little bit more to that? What are a couple examples of the software practices or the ML practices that you've seen happen in the past, and what are you guys doing to remedy those?
Yeah, absolutely. So there's a wide variety of how people approach this problem. But ultimately, the fact of the matter is that, people, data scientists, machine learning experts, and engineers, they spend years learning to do their job, learning the math, learning the models, learning how to work with data, how to engineer features and things like that. It's a very, very different challenge than taking those models and making them scalable and reliable and available as an API that can be hooked into a company's backend data pipeline or hooked up to iOS apps that want to recognize images or whatever the use case is. It's a very different challenge and a very different set of tools, where data scientists and machine learning engineers are often going to be working in tools like Jupyter Notebook in an interactive environment and exploring and experimenting with the data and the parameters and the things like that. When they get to a point where they're happy with their model, you need to deploy it somehow. And So the question is, how do you do that? And there's a number of ways that you do that. Different companies have different approaches. Some will tell the data scientists that they're responsible for, building and scaling their own models. Others will have an ops team or a team dedicated to productionizing these models. But then it's sort of a challenge of, not the same person who's creating the model is the one deploying it. And there's a lot of challenges that come with that.
Stepping into that, talking about sort of these different paradigms different orgs may use in their approach to deploying AI, may I ask a question about data engineer? I think it's a job title that's pretty new. I kind of heard it percolating up maybe about 18 months ago. It seems like it's one of the hottest jobs out there now. Is this a position that is here to stay, or is it going to go away with tools like Algorithmia and all the other companies that are trying to make AI easier to deploy?
No, I absolutely think that it's a thing that's here to stay. This tends to, in my opinion, this is the trend of just computing in general. Whereas, in the earlier days of computing and building cloud and services and applications, you might have more, what we call full stack engineers, somebody who does the whole thing. And that's still true to some extent today. But as you get more mature and organizations are bigger and the projects are bigger, you get specialization. So in the same way as today, you have, application developers, you have DevOps, you have SREs, and, you have all these things which specialize and focus on their one part of the thing. I expect that we're going to see even more of that coming in the world of data science and machine learning as people recognize that there is this whole life cycle of machine learning. The first phase of that is arguably data, getting the data, organizing it, cataloging it, making sure that it's available. This is something that's been going on for, the past 2 decades with everybody talking about, building these data, lakes and data, collections and all that. But that's only the first step. Once you have that data collected, you need to make sense of it and you need to make things actionable. And so then there's, the data scientists and the machine learning engineers come in, and that's their job to engineer the features and work with the data that's been collected and things like that. And then similar to sort of by analogy with more traditional software development, there's the deployment challenge, which I think in and of itself can be, an area of expertise. And that's really where Algorithmia comes in. So we don't focus as much on the early stages of the machine learning life cycle around data and engineering, feature engineering, and those sorts of things. We try to focus on the challenges around how do you actually, build the models, take those models and make them available in production and integrate them with products and, get actual return on investment from them.
So a couple of things come to mind so certainly the data engineer role is an important one. You guys covered that well. What are your thoughts on some of the varied roles of, the data scientist role? I mean, there's a joke that a data scientist is nothing more than a statistician from San Francisco at one time. But in all honesty, Gartner came out and they said there's this classification of a maverick data scientist, and there's also a citizen data scientist, and then there's these, corporate line of service ones, and then your enterprise data scientist. And those 4 entities, what are your thoughts on that distinction? Is there a distinction? And how well, do we serve those different roles? And particularly the citizen data scientist too. What are your thoughts on that as a data scientist?
Well, I mean, in a certain sense, I think that those are the same role applied in sort of different ways or in different applications, or maybe by different personas. Maybe that's the distinction there. I absolutely think it's great that we're seeing things like citizen data science and people recognizing that you can do these things as one person, and it's extremely impactful. In the same way as the early days of the internet, a single person could create an app program or a website and have a really huge impact. I think we're still in the early days of data science where there's low-hanging fruit. There's data sets available that nobody's even really looking at, and it's just a matter of applying some of these methods and tools and techniques that have been built over the years to any of the massive amount of data that's been being made available on the internet and otherwise. I'm really excited to see what comes out of all that.
But I've got a follow-on for that. Talking about personas, you had mentioned Diego had come from the industry side and kind of he had the customer investigation in pocket, sounds like, at the founding.
Mm-hmm.
If there's a typical Algorithmia customer persona that represents a big chunk of the folks seeking help from you. Can you describe what that looks like?
Yeah, absolutely. So largely it's about maturity in terms of not as a company, but in terms of their machine learning approach. Most companies, especially large companies, and the majority of our company customers today are in the Fortune 500 and large enterprises, although not exclusively by any means. But I think one of the reasons why that's been sort of the way that our customers have skewed is because in many cases, they've spent years, first of all, acquiring a lot of really valuable data. In many cases, they're going to have teams of machine learning researchers and data scientists that are trying to make sense of this data and create actionable tools from it. But in many cases, we see that they're really struggling for many of the reasons that I was saying before, where we'll hear about data scientists who've been working on a problem for a year or 2 years, and they may have even succeeded in building models with very good accuracy, 90 plus accuracy or whatever at the domain they're working on, but they haven't even been able to get any of their models in production. In some cases, we hear that these companies tried to build a homebrew solution. Maybe they have tools for deploying APIs and services internally, but what they don't necessarily realize at the outset is that there's a lot of characteristics that are unique to data science and machine learning workloads, which are not necessarily amenable to the existing infrastructure tools and services that are available. Just for some really clear examples of that, specialized hardware like GPUs. If you're not using GPUs to accelerate deep learning models, they're not going to be running nearly as fast. And so if you look at various services, most of them are not going to support GPUs. It's extremely challenging technological problem to share GPUs just because they weren't really designed for this purpose. They were designed to make games run fast and look pretty. It was only later that people realized, like, hey, that same ability to render graphics is basically just matrix operations. It's the same thing that's the bread and butter of deep learning. And so people started using this specialized hardware, but it wasn't designed for the cloud. It wasn't designed to be multi-tenant. It wasn't designed with the same sort of memory constraints and controls that you have in sort of system memory. And so these are a lot of the problems that we try to solve at a technological level with Algorithmia, is making sure that we can support the latest hardware and the latest deep learning frameworks like TensorFlow and PyTorch. Another interesting kind of point about supporting these in an environment is, people say, oh, well, why not just create a Docker image and just ship it off like you would any other service? But the problem with that comes in is, again, related to the GPUs, people treat Docker as if it's a very lightweight VM, but it's not. It is a container, and if you have multiple containers on the same system, they're all sharing the same Linux kernel. And so anything that lives in the Linux kernel, which includes here GPU drivers for NVIDIA, for example, that abstraction of Docker starts to break down. And so suddenly you can't look at it as just this idealized lightweight VM. You have to recognize that it's really multiple applications running on the same machine. And so that presents many problems that again, we work to solve. And it's not that it's insurmountable problems. I think most of these companies could solve these problems if they dedicated enough engineering resources. But the question is why? When they could be focused on their core business, they should have their data scientists focused on building models that are specific to their vertical and applicable to their use case, not just figuring out how to run TensorFlow on a GPU.
So that's a good highlight of some of the challenges with the technology for sure. I'd also like to hear the flip side of that. What is the people factor that makes it difficult for these models to go into production? Are you seeing any challenges around education of the business audience or education of the general populace about prediction or things of that nature?
Yeah, absolutely. And I think that there's different stories with different people at different levels. There's the people who are higher up in the company who are asking themselves, what is our ML strategy as a company? Because they're hearing it all the time that this is the future. And I mean, I agree that in the modern age, it would be crazy to run a business without the internet and a website and using technology to accelerate it. In the very near future, it's going to be the same with machine learning. If you are not using machine learning and AI to help optimize and accelerate your business, you're inevitably going to lose to your competitors who do. And so all of these companies are asking, whether they understand machine learning or not, what is our story around this? And so there's a lot of questions around that at the high level of what is our best practice, what our story. At the lower level, starting to talk about data scientists and machine learning engineers, they're doing what they're doing, and in many cases, they're doing a really good job of building these models, but it doesn't have the sophistication of software engineering that more traditional software does. So in the same way as if you're building an API or you're building a web app or you're building a service, there's all of these best practices and tools and infrastructure and applications that you can use to make your life simple, life better. Some of these are really basic things like Git and source control. Others are things like continuous integration and continuous deployment. All these sorts of things that nowadays, if you were trying to start a company and you were building an application and you weren't using source control and you weren't using CI/CD, you'd be laughed out of the room. I mean, it's just table stakes best practices in that world. But when you look at the world of machine learning and data science, it's largely absent. There's plenty of companies we talk to and we ask, hey, so your data scientists are building these models, how are they keeping track of their changes and the iterations on how they got there? And a lot of them aren't even using Git to source control, their Jupyter notebooks and their things like that to see, how did they build the model? And so part of our mission and part of, I think, what we'll be seeing in the next few years in the industry is just more sophistication in the software engineering side of things. So more best practices, more specialization and recognizing that, you can be a really, really good data scientist, but not know the first thing about how to make an elastic, scalable API that people can rely on. So I think that's a lot of what we're going to see in the near future.
I suspect Brian will come back to address some of the parallels you brought up about CI/CD, for example, and between traditional software engineering and ML. I want to touch on really quickly before I forget about the business aspect of ML. And what you brought up is the competitive landscape. And one goal of 26.1 is to reach business leaders and get them updated on what's going on and who's practicing AI. What's your sense as a founder of business leaders and how they view this competitive landscape? What's their calendar look like in terms of how soon they have to get on the truck, so to speak, and get shipping?
So there's a pretty wide variety, and that's definitely one of the things that we try to feel out as we're talking to customers and looking there is are they serious about this? Have they put deep thought into this? And is it a serious business initiative, or is it a situation of, hey, we heard about this machine learning thing? What is our story? Obviously, the latter is not going to be as compelling because ultimately, the best stories are where you find the right algorithm, the right data, and paired with the right business and the right product, and the results can be staggering. I'm sure you guys can think of examples where if machine learning enabled a company to either one, do something much less expensively than it otherwise would have, which is obviously going to be a huge win, or obviously more exciting is enabling them to do things that they otherwise couldn't do. I'll go back to just the company that I worked at before Algorithmia, just because I have personal experience with it. It was a company called Delectable. It was a wine app. And the premise of it is that you would use your phone to take a picture of the wine you were drinking. It would recognize what wine you're drinking and add it to your personal list. You can rate it as I like it, I don't like it, and you can buy it right through the app. So when I joined the company, they were doing this all by hand. They were literally shipping every image that came into the app to a team whose entire job was to look at the image, search through a list of wines, and select the one. This process would take minutes, not seconds, and then the user would receive a push notification on their phone about what the wine was and if they wanted to buy it. So when I came into the company, my job was basically to bring AI and machine learning to this to make this scalable and feasible. And it accomplished both of those goals in the sense that, one, it reduced their cost dramatically because obviously calling an API costs less than a penny, whereas sending an image to be classified by a human is not going to be so cheap and so easy. But furthermore, it also just fundamentally changed the nature of the business, because instead of sitting at dinner drinking wine with my friends and I get notification about the wine 5 minutes later, once it was hooked up to AI and machine learning, you could go to a wine store and walk down the aisle and just hold your phone up and recognize, each bottle on the shelf and get reviews and feedback and personal recommendations. So it both saved the company a huge amount of money and it enabled new use cases that would have been otherwise impossible. So obviously this is a pretty small example in the scheme of things, but I think it really shows how the right use case with the right business is a huge impact.
So, what is your thoughts on, and I'm playing devil's advocate here a little bit, about the other AutoML efforts? GCP certainly has some right now, and there's H2O and Data Robot, and not just AutoML, but transfer learning in general and reusability. How is that going to play into what you just said about the value of algorithms?
Yeah, well, so I think that there's a couple different things in there. So, I mean, one aspect is the different techniques on how to approach it. You mentioned things like AutoML and various things along those lines, and those will just continue. There will be research advances, and things will get better accuracy, requiring less computational resources to train and work on bigger data, and that's all super exciting. And really, that benefits everybody. It lifts all boats in a certain sense. As the research advances, it helps every company, both on the infrastructure side and the companies that are using this AI and machine learning, really benefit from all of that. To your question about sort of the broader market and the competitive landscape, I think that there's different angles. So first of all, this space is growing so aggressively that in a certain sense, it's a land grab in greenfield space. So we don't worry excessively about competitors in that sense because there's so much opportunity here. That being said, Data Robot is obviously going to be formidable. They just raised a bunch more money, and so they're definitely going down this road. I think
something like $200 million, if I'm not mistaken.
Yeah,
is that correct?
Yeah, something like that. And they're focused a little bit earlier in sort of the machine learning lifecycle in the sense that they're a little bit more focused on the exploration of data and the sort of the training of the models and the building of the models. They're a little bit less focused on the deployment and the infrastructure side, although they're starting to look at that.
Yeah, and you mentioned a little bit about kind of natural language processing problem classes like that and Word2Vec, and have we reached a plateau yet with some of this? The actual machine learning has become commoditized to some degree. And what is the shift now towards feature engineering and application that can resolve some of that innovation ask at the same time?
Yeah, well, to your point about personas, I mean, I think that is an important point, that it's different people who are advancing the state of the art in models. You hear about things like GPT-2 and BERT and all these things that come out and get headlines, and they're super cool technology, and they quickly actually get adopted by practitioners. But the researchers building those models are very rarely the same people as the data scientists who are using those models to apply to the real world. And it is more frequently going to be things like feature engineering and exploration and experimentation on the part of the data scientist. I would agree with that.
The other thing that I see where you're going with everything is addressing maybe a big anxiety in AI right now is the observability of what's going on under the hood. And a lot of that is because there's so little standardization. Is that something that you think you'll be helping in the future?
Yeah, so I think it depends a lot on the use case. There are applications where explainability, if you don't have explainability, you can't use the model. So I very enthusiastically follow a lot of that research because it's interesting. But at the same time, I think that there's a lot of use cases where that's not necessarily the case, that explainability is that important. In many cases, it's going to be more about results and accuracy on the domain that you're targeting. And just because something is explainable doesn't mean that it's not doing the wrong thing. And so I think that the focus should be more on making sure that the models are doing the right thing, that they are not causing problems, obviously, but explainability isn't a magic solution to that. So I would say that that's going to be part of the solution. It's not going to be all of it. Related to explainability, but a little bit subtly different, but I think in a certain sense more important to a lot of enterprise customers, is not explainability of the models, but accountability for how they were generated and where these things are coming from. And we work with companies, say large financial companies, that say, we can't use a model unless we know exactly how it was generated. And so that goes back to the point I was making of, people need to be adopting better best practices around this. They need to be source controlling the code that generates their models, not just the models themselves. There needs to be versioning on the models of, historical versions of, here's the evolution of this model over time, so that we can see, is it getting worse? Is it getting better? Are there subsets of the data that used to perform well but now are not?
This has been great. And I'd like to give you a chance, just a final note, maybe a sentiment or a leave behind, as we want to keep this down to 26.1 minutes. Kind of a, what is your final mark on this one, and what are you thinking the future is here with this?
So ultimately, we're really excited about just where the space is headed. We got lucky in a certain sense that I've been obsessed with AI and machine learning since high school, honestly, reading books and Penrose and all those things. And so we were an AI and machine learning company really before the recent sort of hype trend, we'll call it, started. And so I don't think it's just hype, though. I think that the point I was making earlier, this is going to be hugely impactful to businesses in the same way that the internet and networked computing was. And so for us to be in on the ground level, ahead of the game, talking about best practices and infrastructure and scaling, and then seeing firsthand a lot of these companies that are recognizing that this is going to be important, they're taking it seriously, and they're trying to figure out, what is our machine learning story and how are we going to leverage this? That's a really exciting place to be in, and it's going to be really exciting to see where the industry goes.
That's a wrap. Thank you for joining us on AI Podcast. You can reach us at ai-podcast.com or find us on Spotify or iTunes. Thank you again, and we'll see you soon.